Or my contacts. And I was driving.
She's like.
I mean, like this.
You're better than that number class. Yeah, you can do it. First, yeah, a bunch of things. And you finished your work. No, I didn't know. It's not to do. All right, we got.
So I think today is pretty easy. You know that you can use inverse tangent to find the angle. So we're really just working with that from a geometric and also from a vector standpoint. Let me just review what we were able to achieve at the end of last week. So let me just go over a couple of the problems from page 5 in your packet. So we talked about how vectors have two special properties. One is that it has a certain magnitude, has a certain length, certain value, but also has a certain direction. If we think in terms of count how many units down and how many units to the left or right that it moves, we can figure out the direction, but also the magnitude. So for instance, the last few problems here on page 5, number 4, I have vector x plus vector 3w. And vector x, I'm just looking at what the behavior of vector x is. It's starting at the tail and moving to the tip. So I'm going up 5 units, to the right 5 units. So I'm also applying that for vector x. Doesn't matter where I start, but if I kind of have an idea where the graph is or what direction it's going in, I can kind of save space and not run out of room. So I started in the middle, as far left as I can. I went up 5 over 5, and then plus 3w. So I just take what w is doing, and I just multiply those directions or movements by 3. So it's going to be 4 down, 2 to the right. So it's going to be 6 to the right and 12 down. Right? It's 4 times 3 is 12. 3 times 3 is 6. So we left off at this point. So then w, the second vector, will pick up where we left off, and we just go down 12 over 6. Now, once you have your 2 vectors, then you're going to create your resultant vector. Resultant vector is where you started at the beginning and where you end up. And you draw a straight line between it, and your arrow is always going to point toward the destination. Okay. So then all I asked from the section, once you draw your vector, your resultant vector, is to find the magnitude. So the magnitude is what's the length of this. So imagine you just treat every resultant vector as a hypotenuse of a right triangle, of an imaginary right triangle. And I can imagine a right triangle here. So I'm going to go down 6 units. Sorry, I'm going to go down 8 units and over 10 units. So go put that in the Pythagorean theorem form. And if you're looking for hypotenuse, it's always the square root of the sum of your horizontal and verticals. Right. I'm sorry, number 4 was right, down 7 over 11. Yeah, sorry, down 7 over 11. So square root of 7 squared plus 11 squared. Same idea with 5 and 6. You pick a point to start, you move in the direction that they're asking you to move, and then once you have your 2 results or your 2 vectors, then you draw your resultant vector from your starting point to your ending point, and then you're just creating a magnitude value for your resultant vector. Okay, any questions? Okay, so let's turn to page 6. Okay, so today we're just going to do pages 6 and 7, and then we'll put things together with a task tomorrow. we're not gonna have to do this on the test, of course. I'm gonna just skip this part. But really, we're using, tractor and we're using, rulers to measure, the angles. But I'm just gonna just skip this part and, go down to, the halfway down. So, because the work that we need to do is from a more of a calculation perspective. So halfway down, page 6. Okay, so I'm gonna start notes in the middle here. When the grid is used, first find the component form. So a component form is basically, what we did, when we were, finding these behaviors, right? Is it moving 4 down or 3 to the right or 8 to the left, right? So basically think of it as your horizontal and your vertical movements. That's component form. So horizontal displacement, how much movement is my vector going to travel, from a horizontal perspective, and how far up and down is it going to travel? So displacement is how far, the horizontal vertical component is of your right triangle. So, we're going to use, Pythagorean theorem to calculate the magnitude of the vector. We talked about that. So I'll use V for vector, and then the, absolute value. It's not absolute value, but then the vertical bars is the notation for magnitude. So is the horizontal component square plus your V squared. And I'll just let A represent my horizontal component, and I'll let B represent my vertical component. Also, you can think of it as horizontal displacement and your vertical displacement. So component form, it's going to be in kind of like these angled brackets. And then we're going to use trig to help us determine the direction of the vector. So theta is equal to inverse tangent of B over A. Or opposite over your adjacent. But we gotta be careful because the calculator is not always right, meaning that the calculator will give you a reference angle, but we just like how we did in previous units. If we know that something's in the second, third, or fourth quadrant, we have to make an adjustment, right? Add or subtract from 180 or subtract from 360. So that's why the calculator is not always right, because calculator provides or only provides reference angles. So if we know that the vector is pointing into that third quadrant, we have to recognize that 40 degrees is not correct, right? It's going to be 40 plus 180 to push it into the third quadrant. So let me just go through a couple of these examples, and I think you'll find this very familiar because you've already demonstrated on that first day when we were doing all that trig review. So it says find the component form, magnitude, and direction using standard position. So that just means give a degree measure between 0 and 360 of vector D and vector E. Okay, so first let's do component form. I use these chevrons or these angle brackets here. We're going to start at the tail and we'll move to the tip. Okay, but we're always going to do horizontal first, followed by vertical. So we got to count how many units am I going to move to the right? 4 units, so 4, comma. And then from there, you're going to move up how many units to reach the tip? 3. There it is. There's your component form. Okay. Right is positive, up is positive, left will be negative, and down will be negative. But the first number is always your horizontal movement, and then the second number is always your vertical movement. So let's find the magnitude first. Magnitude, that's the easier one. Inverse tangent of b over a. So if we're trying to find this angle here, we're always doing opposite over adjacent. It's always going to be your y over your x value. Okay, use your calculator, make sure you're in degree mode. What do you guys get? Oh, I'm sorry. I did the direction first, my bad. Magnitude is the Pythagorean theorem, sorry. Well, we'll just do direction first. And then we'll do magnitude. So direction 36.87 degrees. Now, do we have to make any adjustment with this? This is okay, right? The reference angle, the only time reference angle doesn't need to be touched is if you're dealing with the first quadrant, okay? Because then it's nice, it's the same as your angle from your first, from a standard form. So first quadrant is easy. It's only second, third, and fourth quadrant you have to make an adjustment. Okay, so now magnitude. Okay. We know that c squared is, or this hypotenuse is square root of a squared plus b squared. And you can just pick off from component form, because once you have your component form, your direction and magnitude will just be using those numbers. Square root of a squared plus b squared. So I can say the magnitude of vector d is equal to, and I'm going to use that notation for magnitude, is equal to what? 5. Okay. All right, let's look at E here, component form. We always do horizontal movement followed by vertical movement. So which direction am I moving first? Left, 1, 2, 3. So how would you represent that? Good, -5. And then vertical movement, 4 units up, positive. And so the sign is important, right? Left is negative, down is negative, right is positive, up is positive. First number is always left and right movement. Second number is always up and down movement. Okay, magnitude. Okay, let's practice the notation for magnitude. We're gonna do the absolute, or not the vertical bars. Now I'm taking a bit of a shortcut here. Why do I not put -5 there? Yeah, because I know that if I'm squaring all my a and b values, I'm just going to ignore the negative because it's going to end up being positive anyways. Now, if you really wanted to put a negative in, you'll do a parentheses -5 squared, but it's if you know what's going to happen after a squared, you can just leave out the negative. I'm so my bad, guys. What did I do wrong here? it's y over x. It's the vertical over the horizontal. Right, so because our tangent is always going to be opposite over adjacent, it's always going to be b over a. It's always the vertical component divided by the horizontal component. Okay, so that's what the calculator gives me, but which quadrant is this vector pointing in? Second quadrant. So how do I get this into a second quadrant measure? Yeah, so I know it's going to be 180 minus 38, right? And the reference angle is 38 degrees, but I know that if I want to get to the second quadrant, I'm going to do 180 minus 38. Because you know that you're looking for an angle measure between 90 and 180. So the only way to get there is to subtract 180. Make sure you never touch 90 or 270. I see some students wanting to subtract or add from 270 or 90, but your reference angle is always working from the x-axis. Okay, any questions here? So the next page, we're just doing more of the same. We may have additional work in terms of we got to build our way to the resultant vector. And then once we get that resultant vector, then we do this. But if you understand this concept, that's good because we're just going to practice these three things over and over for the next page. And that'll be it for today. Okay, so page 7. Use the vectors to the right to complete the problems 1 through 6. Round answer to the nearest thousands. Use standard position for the direction of a vector. Okay. First it says find the component form, magnitude, and direction of vector x. That's an easy one there. So I'm not going to say component form anymore. I'm just going to go ahead and write the notation. So remember, we always start at the tail and move to the tip. So what's component form for vector x? Close. Yeah. We're moving left, so -5, 0. Yeah, there's no vertical movement. Okay. Once you have vector form, sorry, component form, then all you need is to look at these numbers to get to your magnitude and your direction. In this case, you can just count, right? Because if it's a horizontal or vertical, you can just count the distance. But Pythagorean theorem still works. This should be easy, right? We don't have to go through trig here. Which direction is it pointing in? What degree measure is this? 180, right? Yeah. Okay, try number 2. Component form, magnitude, and direction for vector u. Right, so vector u, I went left 4 units, down 1 unit, so that's why they're both negative. Pythagorean theorem will get you to your magnitude. And inverse tangent of -1 over -4, I got 14.036. But which quadrant should this be in? Third, so what adjustments? Add 180. So number 3, we're going to create vector A, which is our resultant vector. Vector A is 2u minus w. So if we think about what's going to happen here, 2u, that means we're going to have to double the length of u, and then minus w. W is going this direction, so minus w is going to make it go what? Up and to the left, right? So we know our u is going to extend, but then it's going to go up to the right. So I'm going to start as far right as possible because I know I'm going to have to build my u down, and eventually, the w will take shape. So I'm going to start around here. All right, so my u is here, right? So -4, -1. If I double that, what's my motion going to be for 2u? -8, -2. Yep. So let's go -8 over and down 2. Minus w. All right, so if you think about w, I'll just put the vector component form for w. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's down 5 to the right 5. So if I'm doing a negative w, I know I'm going to change those signs here. I'm going to go to the right. I messed up. Horizontal movement first. So right 5, -5 down. So negative w is going to take that and go the opposite direction, right? Instead, I'm going to go left 5 and then up 5. Left 5, up 5. So I'm not going down and to the right, I'm going up and to the left. So the vector that we really care about is the resultant vector that's going to start at our starting point and end at our destination. So in the end, we just care about this vector here. This is vector A. And everything that we're asking for is just for vector A. We don't care about the intermediate ones. Okay, so now I want to find component form for vector A. I'm going to count how many units to the right, left, and then going to count units up. So count units to the left. I know that's going to be a negative. So it's going to be 13 units across and 3 units up. Once you have your component form, then that's all you need to look at to build your magnitude and your direction. Okay, which quadrant is this vector A pointing in? 2, so I got negative 12.99, so how do I adjust that to get to where I want to go? Yeah, because I know add 180, same thing as 180 minus 12.99. That's going to land me in that space between 90 and 180.
The resulting vector is like.
Right. So it says 2u minus w, right? So 2u is, I start here and I move down to the left. And then negative u, I got to go left and up. So I'm beginning here and ending here. All I'm doing is I'm just drawing a line from my beginning to my ending point, and I'm going to draw the arrow where my ending point is. Yeah. And once you have your resultant vector there, then you see where it's pointing, and it should be obvious to you which quadrant it needs to be in. And then you can decide, do I need to add or subtract 180, or do I need to work with 360, right? Just depending on where your final arrow is pointing. Okay, number 4, draw the vector diagram. So now this is a bit more complicated because I got to create 3 separate vectors, but then ultimately my resultant vector is, where do I start? Where do I end? Draw a line between those 2 points and then just draw an arrow towards your destination. Okay, let's map this out a bit. We want to go vector W. So I got to go down and to the right first. And then 2V, I'm going to go straight up. And then plus X, I'm going to go to the left. So I got to go down and to the right, up and to the left. So I'm going to start as far left as I can. I have some limited space here, just to give myself room for, let me see. Give myself a bit more room here. Let me go down. Yeah, give you a lot more space on a test or quiz, so you're not having to figure out where you need to start exactly. So we'll start with W. So W is to the left 5 and down 5. Plus 2V. So V is up 4 units. So that means I'm going to go up 8 units, because V is 4. So double that, I get 8. And then I can go in the direction of X, and X is moving to the right 5 units. So I start here, I end here. So I'm just going to draw a line from my starting point to my ending point. So this is my resultant vector. I moved it slightly to the left so I can see it above the so my dotted line feels more apparent, but you get the idea. I'm just going vertical up. Does that make sense? How to build your resultant vector? What's my component form for vector B? Good. It's just going straight up, so no horizontal movement. Vertical movement of 3 units. Okay, magnitude, Pythagorean theorem. I don't have to go through Pythagorean theorem really because it's vertical, so I can just count, right? To me, just 3 units. Direction, if I'm going straight up, what direction is that? 9 degrees. So if it's easy vertical direction or horizontal direction, you know it's either 0, 180, 90, or 270. Yes.
So when you have a negative, is that shoot something that doesn't have like an X or a Y value, it's just 0? Is it just flips the other way, or do you flip it on the axis?
What do you mean?
So like negative X or vector X, would that just be going to the right?
Well, because X is defined as going left, so I have to go the direction that X is going in.
But if it was negative? what would
Yeah,
you-
if it's negative, then I'll have to go the opposite direction of going to the right.
Okay.
Yeah. So we're always basing it off of what they give us, and then either they're asking us to use the direction that it's going in, or if they're asking us for the opposite direction, then they'll put a negative in front. Yeah. Yeah, so negative doesn't always mean left. Negative just means it's the opposite direction of what they're telling you is the normal direction. Okay. All right, we'll just finish up with 5 and 6. All right, so W is going to go to the right and down 5 units. Minus U. So U is originally going -4, -1, but negative U is going to change that sign, right? So then I'm going to go to the right 4 and up 1. Hey, I started here, I ended here. So that tells me how to draw my resultant vector. And my component magnitude direction is just my resultant vector. I don't care about those initial ones. Okay, so I start here, so I count to the right and I count down. So positive, negative. Okay, which quadrant is this vector going to end up being in? Pointing in the 4th quadrant, right? So what do I do with this theta? Yep, 360, good. 360 minus 23 will land me in that space between 270 and 360, which is safely in the 4th quadrant. Yes.
Use with 3, the 3 you counted to the left and then up on 5 you counted to the right and then down. That's the
Right. So the meaning, the reason for that, for you, so we understand U is left 4 and down 1, right? But it's not U here. It's negative U. So that means we gotta go the opposite direction of U, which means I gotta change these signs here. So +4 and +1. So I gotta go 4 units to the right and the 1 unit up.
I mean, for like, I meant for counting the components.
Got it. Components.
Why,
Uh-huh.
I mean, if 5 is 9, -9, 4, why is 3 not? I mean, so if 5 is 9, -4, why is 3 not 13, -2?
Okay, the reason why is because we started here and we ended here.
Oh.
So we have to count in the direction that we're traveling from the beginning to the end. So wherever the arrow is pointing and where the dot is, then that's gonna determine our sign and our direction of motion. Yeah, okay, good. All right, last one here, number 6. Let me give you a starting point, because you have such limited space here. Let me give you a starting point here. Let's see. Start here. Okay, so we'll do 2U. So again, we got to double our vector U. So 8 left and down 2. Negative W. So if you look at W, W is 5 right, down 5. So negative W is going to be left 5, up 5, right? So left and up. And finally, negative X. So X is traveling to the left normally, 5 units. Negative X means we got to make it travel the other direction, so it's going to go 5 units to the right. So we started here, we ended here, so that's going to tell us how to draw our resultant vector. So resultant vector is all we care about for all this following information. We're going to count left and up. Magnitude, you only need these 2 numbers to help you with magnitude and direction. Okay, so my calculator gave me negative 20.556 degrees, but which quadrant do we need to be in? Second, so I need to do it with that negative 20. Yeah. So just keep observing your degree. Make sure that it's landing in the quadrant that you're expecting it to land, because let's say you accidentally did 20 plus 180. If you look at a number like 200, you realize, wait a second, this is not quite second quadrant. And so hopefully you can make that adjustment and make sure that you're in the correct quadrant that you're supposed to be in. All right, good. So tomorrow we'll be building off of this information with a task that we'll do tomorrow. Okay, you can come get your phones.